Welcome back, children. In the previous video, we have learnt about annuity and various terminologies that we use in solving the questions of annuity. I have provided you the link in the description box. If you want to go through those definitions, then you can go. In this video, I am going to introduce you two formulae. First is for amount or future value of a regular annuity, and second is how to calculate present or capital value of a regular annuity. So you will be getting only two types of questions. One, where you want to find out amount or future value, and secondly, when you want to find out present or capital value. We are not diving into the derivation of the formulae of these two, but we will be directly using the formula over here. So if you want to find out amount or future value of a regular annuity, then you will have the formula A equal to R 1 plus I raised to power n minus 1 whole upon I. Now this A is your amount which you want to calculate. So this is your future value. This R is nothing, but this is the payment which you are doing after equal interval of time, or I can say periodic time. Alright, so this R is the installment which you are paying, the regular installment which you are paying. This I is your rate of interest at which you are paying it, so it is R by 100. So I is R by 100. So here we have written the amount or future value in terms of I, where I is rate by 100. So this is your rate. Since we have used R in the formula here, that's why I am not using this R over here. Otherwise you will get confused that what is this R and what is this R. So we have denoted R by 100, that is the rate, with I. Now when we want to find out present value or capital value, then what we do here is we can write it as present value is equal to R, but here in place of 1 plus iota raised to power n, what we do is we just invert this term and we write 1 minus 1 plus iota raised to power minus n upon iota. So these are the two formulae which we are going to use to calculate the future value or the present value. Children, now since in these two formulae I am getting 1 plus iota raised to power n and here I am getting it as minus n, then how we are going to solve it? Children, we need to use logarithmic rules and tables over here to solve the question. Let's see the first question, how we can apply these formulae and log values. Let's just see this question, children. Find the amount of a regular annuity, that means amount is to be calculated, of rupees 5,000 payable at the end of each year. That means your R, the amount which you are paying, or I can say the periodic payment, is given to you as rupees 5,000 for 3 years. That means time, and time is denoted by n in the given formula. I am writing the formula right now. N equal to 3 years, and R is given to you as 10%, and in the formula it is used as I, so I will be writing it as 10 by 100. So this is the value of I. Simply I can write it as 0.1. Alright, now the formula is A equal to R 1 plus I raised to power n minus 1 upon I. Now let's just put the values. R is given to me as 5,000. Here it is 1 plus I is given to you as 0.1 raised to power n. N is given to you 3 minus 1. Again, this is your 0.1. Alright. Now children, here you can solve it like this. I can write it as 5,000 into, this is 1 plus 0.1. I can write it as 1.1 raised to power 3, and this can be written as minus 1.1. Alright. Now there are two methods to solve it. Either you can multiply 1.1 3 times which will give you 5000 into 1.331 minus 1 whole upon 1. I can write it as into 10. Alright, you can simplify it, or if you are comfortable with the log table, you can let this as your let x equal to 1.1 raised to power 3 and then take log on both the sides. So using the property of log m raised to power n, which gives you n into log m. So here I can write it as 3 into log of 1.1. Alright, now you can find out the characteristic and mantissa of 1.1. So after getting the characteristic and mantissa, you will get it as 1.331. This is smaller power, so you can multiply it 3 times. But if it becomes more than 5 or 6, then in place of multiplying, please use your log table. So on calculation, we get it as rupees 16,550. So the amount here is rupees 16,550. Let's see another question. Let's see this question. Find the present value of a regular annuity of rupees this. That means it is given to you as R, which is rupees 1,000. N is given to you as 3 years and I is given to you as 12 by 100, or I can write it as 1.12. Alright, now write down the formula for finding the present value, which is R. Here it will be 1 minus 1 plus iota raised to power minus n whole upon iota. Let's put all the values over here. So it will be 1000, 1 minus 1 plus 0.12 raised to power minus 3 whole upon 0.12. Alright. Now as I told you in the previous question that whenever the power is greater, then you always use log. And here you are getting it as minus 3. So it's better to use log table over here. How you can use it? You can write it as 1000. This can be written as 1 minus 1.12 raised to power minus 3 whole upon 0.12. Again, here you can take it separately. Let x equal to 1.12 raised to power minus 3, taking log on both the sides. So you will be getting it as log of x. And this will be log m raised to power n. So you will be getting it as n down minus 3 log of 1.12. Now what you need to do over here, you have to find out the characteristic and mantissa. So here, first of all, you will be looking at the characteristic. Since one number is there before decimal, so characteristic is 1 minus 1, which is 0. So you will be getting it as minus 3, and then you will be looking at the log table as 11 in second column. 11 because your log table starts from 2-digit number, so you will be looking at 11 and you will be finding in second column. So at looking the log table, you will get it as, so this is the value which you are getting here, but I need to get the value of 1.12, and which I have taken it as x, but here I am getting it as log of x. So to get the value of x, again I have to take anti-log on both the sides. So taking anti-log on both the sides, so anti-log of x is equal to anti 1.476. Now you have read that anti-log and log will cancel each other, and here I will be getting just as x. So x equal to anti-log of this. Now you have to see the anti-log. Whenever we look at anti-log table, so this is your characteristic already given, and you need to see in the anti-log table as 0.14 in column 7, and then you have to add your index number value in the column 6. So when I look at the anti-log table, I'll get the value as, so this is the value which I am getting in the anti-log table, which is 0.7119. So put it here, this is 1000 and here it is 1 minus this complete is given to you as 0.7119 upon 0.12. Now subtract and do the solution. So on solving this, you will be finally getting the value as, this is your present value of the regular annuity which you are paying your R as, or the periodic payment as 1000 rupees. So rupees 2400.83 is the present value of the given regular annuity. Have a look.